Factory in Vero Beach, Florida. I'm glad to have you along today for a tour. We're starting actually in the main entryway to the factory. We have currently 700,000 square feet of factory space, as well as 750,000 square feet of ramp space. The Piper factory in Vero Beach opened its doors in 1957 primarily as an engineering test facility. So the objective was to take advantage of the wonderful year-round flying conditions to test and develop aircraft. A few years later, we opened this building here in 1960 to build the Piper Cherokee, which of course we still build 4 different derivatives of that aircraft today. So I'll go ahead and take you through the factory today. We built 8 different models of aircraft in the factory line. And amazingly, there's 2 primary production lines. So the 2 production lines are the Malibu line, which of course many of you are aware of the Malibu, which basically began its roots in 1984. Today we build 3 different derivatives of that model, which is the M600, the M350, as well as the M500. The second production line is the Cherokee line, which of course this is where that plane was developed. And we run the Archer, the Arrow, the Seminole, and the Seneca down that line. So as we enter into the factory here, off to the right is our welding facility. Interestingly enough, Piper welds and creates all of its engine mounts. They're made here by our craftspeople. We have, we're currently a 95% vertically integrated company, which means we basically build or manufacture the majority of the components that go into our aircraft. Why do we do that? Well, we do that because that gives us greater control over the quality of the finished product. So we'll keep walking. This is our tooling area. We develop the vast majority of our tooling so that we can build aircraft. In fact, they maintain roughly 133,000 tools to build our aircraft, so that keeps them quite busy, but they're actually masters at their jobs. So what we'll do is we're going to take a kind of zigzag tour around a little bit. We're going to come down here and look at some of the advancements that have been taking place over the past few years. We employ right around 1,000 employees here at the Vero Beach facility. At any given time, we're actually running roughly 3 shifts at this point in time. So we'll have on the primary shift roughly 600 or so employees, and then it'll go down a little bit as we go into some of the later hours at night. So over the past several years, the company, in fact, last year specifically, we invested roughly $10 million in capital improvements, in tooling and equipment. And as you can see, over the past several years, we've added this bank of mills and lathes, and we replaced a lot of the older equipment that we have been using historically.
With those capital improvements, was it necessary to do that because of the new technology going into all the planes?
No, it really wasn't. The objective was to become more efficient and better manage the hours that it takes to build an aircraft. And so some of the equipment was aging, and with the advancements in technology in general in manufacturing, there's equipment now that you can buy that reduces the number of steps that have to take place on other machines. So we can consolidate a lot of the work into one machine. So for those of you who own obviously a PA-46, one of the most important investments that we've made most recently is this gantry mill. We purchased that piece of equipment so that we could bring the production of our spars in-house. Previously, we had an outside vendor that helped us with the manufacturing of the spars for the aircraft, but with the goal of really trying to control quality, it was necessary to expand our manufacturing capability and bring that equipment in-house so that we could make the spars in-house. And you can see here, we start with this basically billet of material, and at the end of the day, this is just a sample of what the end product can look like when we're making a spar. The company had a bag press that we used to form quite a few parts that we make. The bag press was aging very, very quickly. In fact, there were only 2 running in the world, one here and one in France, which was its sister. And it's called the ASEA bag press. Well, we've recently replaced that with this new one. The smaller one here to the right was kind of the backup until its big brother could arrive. This one arrived about a month ago, and it just came online last week. We currently run roughly 1,600 different parts through this piece of equipment, and it's really, really helped improve efficiency. We are still continuing to use, for the time being, the ASEA, the older piece of equipment. Over time, we'll eventually retire that piece of equipment and just focus on this. The smaller bag press will return to the manufacturer here in the coming months. So last November, this equipment arrived, and it took several weeks to get the equipment online. But what you have in front of you here on the right, that is a laser punch combo press. And what it does primarily is it uses laser to cut sheet metal, but it can also has a turret inside where it can punch holes, very, very small holes through materials. And it's incredibly exact. If you look here, you can see how small the holes, they can get even smaller than that. And the way this machine works is the metal feeds into it, and the metal actually is, you can see it actually cutting now and punching. This machine here is specifically a laser cutter. And it can accommodate a thicker piece of metal, which is why we have 2 different pieces of equipment, because the capabilities are different. But because we added this piece of equipment, we're able to, previously we had a piece of equipment that did all the punching, then we'd take that finished product out and we'd have to deburr it. So we'd have to basically grind off any metal shards that still existed. But because of the way this machine operates, you're left with such a clean, finished piece that you now don't have that extra step of work. What they're also doing, a lot of the equipment that's behind you, this older blue equipment, they're in the process of working through offloading some of the work off those machines, and some of it will filter into this machine over time. But it's drastically improved our efficiency because it's a lot less steps. And what they can do is they can load a pallet of metal in there and it'll continue to run. So what they'll do, like in the evenings, they'll load a tray of metal and it'll run until the tray is empty. And we don't necessarily have to be here supervising it. Also last year, we added what we would call additive manufacturing, right? So it's the use of 3D printing to create Class 3 parts for our aircraft. So a Class 3 part would be something like an air conditioning vent, a component to the environmental system for the aircraft. So they're parts that are not critical to any particular stage of flight. So at this time, we manufacture roughly 400 parts through our 3D printing process, and we can actually go in and take a look. So this one's running now, and it prints the parts. So the way it works is it lays down, you can see it laid down a layer of powder. It passes it with a light to activate it, but it first starts with like an ink. So it's ink, powder, light. And it continues to layer until it's done creating the parts, and then it fills this entire bin with parts, and it's making one specific part at a time, right? So it could be the air conditioning vent or the climate control vent that's in the back of the PA-46, and it'll make a bin full of those. Then and it's using a powder, whereas some of the 3D printers originally it was like a spool of plastic. This is a powder. So once they're done, they basically have to, it's like an archaeological dig, they have to pull out all the excess powder, pull out then the parts, then the remaining powder that wasn't used, we run it through a recycling process and it gets used again. And some of the parts you can see here, these are what some of the finished parts look like. And then some of them they've even created, this is a fully 3D printed part that has the ability to actually function, which is just incredible. And again, really improved our efficiency, because this can run until the bin fills and is emptied, so we don't necessarily have to be here monitoring it all the time. But additionally, some of the components we used to make, we purchased from outside vendors, and to get them to work within our products, we had to make additional changes to them. So the labor hours were much higher. So now we're much more cost effective in the production of some of these Class 3 parts. In the history of our company, we've manufactured just over 144,000 aircraft. 70,000 or greater airplanes are still flying today. But that means we have to support those aircraft. So behind you, or just over to my right, your left, is, I consider this like the card catalog of tools for aircraft. So if someone calls our parts supplier and says, hey, I need a component for a 1969 Cherokee, then we can go here, pull the tool, and create the part if we don't already have it available through our logistics provider, which is Boeing, by the way. So the bulk of the parts, as they're made, they come through a wash process. They're cleaned and of any contaminants. We also run a small parts paint area here so that we can prepare them to go in the aircraft, provide some anti-corrosion, an anti-corrosion layer to basically protect the material. So you'll notice as you walk through the factory, you don't necessarily see an airplane right away. You see things look like they go in airplanes, but as you progress through the factory, it becomes very evident that airplanes are being built here. So this section of the factory is our sub-assembly, which is where they're doing a lot of small parts assembly, very detailed oriented. But this team plays a very critical role in the manufacturing of our aircraft. So this is our avionics lab, where they basically build up all the avionics systems for each aircraft that we build. Every aircraft has its own wire harness assembly that needs to be created. And Piper is unique in the fact that we still do all our own wire harnesses, which is quite rare, frankly, in the industry. A lot of manufacturers outsource that now, but we continue to do that in-house. And you can see each model of aircraft has its own map, and then it evolves depending on what spec that the aircraft's being built to and what equipment or options the customer selected for that aircraft. Once they've kind of gone through the process, number one, of building the wire harnesses, and then B, getting everything set up for the avionics installation. Here, very clearly, this is a G3000 avionics installation, which is always evidenced by the GTC 570s. This is what we have before it goes into the aircraft. And you can see there's an immense amount of wiring that needs to be included, as well as quite a bit of equipment that needs to move with this avionics setup. A couple of things that are important to know. We've started using this material here to protect the panel, because it's easy to scratch when you're installing the LRUs and the GTC 570 screens. So we try to come up with processes that will protect the finished product so that they look beautiful when the customer comes to pick up their aircraft. But again, there's just an immense amount of work that goes into the avionics, and I feel like they just keep getting more and more complex as time passes and technology advances. Every time you turn around, you're trying to look for space for another piece of equipment. This is actually getting ready to go in an aircraft. In fact, so here's a fun fact. So this is the serial number range for the M600 SLS. This is serial number 150. This team up here is kind of the unsung heroes, right? Because they aren't seen as frequently as a lot of the people on the shop floor, and it's just incredibly tedious, and it's an immense amount of attention to detail to get these systems installed properly and have everything working correctly, because of the avionics obviously is a critical component to the aircraft, as is the power plant. So fun evolution over time. You know, several years ago, we were only building a handful of trainers each year. And the past few years, we've been building over 100 or so Archers, upwards of 30 to 40 Seminoles. So that Cherokee line has gotten very, very busy. So we've made some changes to the factory. So for any of the people watching this tour who've been here before and are familiar with the trainer line, you'll see this theoretically used to be kind of the end of the line. And at this point, you would see something that looked like a completed aircraft. Well, we've moved final assembly to another hangar because there's just so much volume. So in order to make space and better configure the factory floor, we basically get the bulk of the components built here, and then they move over to the hangar. We call it Hangar 21 or Building 21, and that's where final assembly is now located for all of the Cherokee line. So behind me, we have where we do the engine buildup, which is interesting to a lot of people, though. We have a Lycoming engine we're building up, but you can see a number of Pratt & Whitney engines that have arrived. We got the engine mounts ready. Yep, and we have some incredibly skilled craftspeople that take the time to get the engines ready to be installed here on the final assembly line for the PA-46 line, or what we call the Malibu line. We've been using the Lycoming since about 1989. Yep, and we continue to use that same power plant in the M350. And then when you look at the 500 and the M600, they both share the PT6-42A engine. Of course, they're slightly different because the M500 has 500 shaft horsepower, and of course the M600 has 600 shaft horsepower. But as you can see, they've got a number of engines they're getting ready to work them through the process to prepare them for installation on the aircraft. So this year, even with the pandemic, we'll build roughly 233 airplanes. So that's roughly about 4.5 airplanes a week. So certainly continuing to keep quite busy with all of our manufacturing. So as we get into this aspect of the factory, this is clearly the Malibu line, where we are getting to the final kind of stage of assembly, and we're preparing for the aircraft to what we say OFD, out the front door, to go over to the flight line. And what's kind of fun, and a lot of people, we tell them this when we get here, when airplanes are at the factory, the airplane to us is known by serial number, whereas when you get out in the marketplace, people refer to their airplane by registration. But at the end of the day, we don't know ultimately, we don't always know exactly what the registration is going to be. So you can see here 770 is the last 3 digits of the serial number on this M350, followed by 148. Anything in a 100 series right now is going to be an M600 SLS, which, if you remember, we were up in the avionics shop and we saw the G3000 build up for the 150, which is going to be coming right behind it. So fun fact, so here you can see one of the M600 wings. It's just an immense amount of detail and work that goes into building this robust wing. And what they do here is they get the wing built up. It comes over here as they finish getting it ready. And just down line here, they get ready for wing mate, which is kind of a key milestone in the build of an aircraft. So they'll bring the fuselage over, and you can see they're actually getting ready to do a wing mate right here. This is 150, so remember the panel upstairs, this will be M600 SLS 150, and then that panel that we saw up in the avionics shop is destined for this aircraft, this fuselage. And its wing, I am guessing, is right behind us. So they're preparing this fuselage to be mated to this wing, which again, key milestone, followed by probably the next most significant milestone is engine hang. Then it'll roll out the front door, and it'll go over to the flight line. They'll finish getting the avionics set up. They'll run through a series of significant tests to make sure that everything's functioning properly, and then it will go on its first flight. And usually the first flight is not terribly long. It's usually maybe an hour or less. They'll do that, they'll bring it back, assuming everything has flown beautifully as it normally does, then we'll take the aircraft over from flight line to the paint shop and we'll start going through the process of installing the interior. We now have a max range of 1,658 nautical miles, and it gave us the ability to carry a lot more payload, which was one of the things we really wanted when we were looking at the M500 or the Meridian. What was going to be next? Well, we wanted more range and we wanted more payload, and I think that the M600 really delivered on that. And now with the SLS having the auto end capability, it's really rounded out that product beautifully. So we're one of the few manufacturers, as I mentioned, that basically builds up our own interiors. We have a number of different interior configurations that we manage, given the fact that we have 8 different models of airplane that we're building. But in general, the trainers have kind of one general interior, and then the M-Class has their own interior that's obviously more upgraded, given the fact that we're dealing with customers who own those aircraft and fly them for both personal and business use. So you can see, we'll do one over here. So as they build up the interior, they'll get everything staged here on one of these, carts, and they do them for all the aircraft to be prepared to be installed in the aircraft. So this interior here, they're preparing for the installation. Obviously, it's a lot of it is, well, it's all handmade by our craftspeople here, and you can see how they build up the seats. And of course, the M600 in particular has a package available called the EXP package, and that allows the customer to kind of personalize the interior. So they can pick, obviously, from a variety of different interior color palettes, but then they're given the ability to personalize with either a embroidery stitch, or we also do there's a process called debossing where we stamp the leather. They also have the ability to pick different stitch patterns. This one here in the Sequoia interior is actually the diamond stitch pattern. And customers can pick a variety of different patterns if they want to go down with that, if they want to have that look for the aircraft. They also have the ability to pick different color threads. And it's really given customers the ability to kind of put their own personal touch on an aircraft. So fun fact, for the M600, some of the interiors have like a carbon fiber accent component, and this is the ceiling bezel, which is truly a carbon fiber piece. It's an immense amount of work to make this look completely uniform, because it's such a long stretch of material that runs through the cabin. So typically they'll bring the leather hides, they'll put them on this table, they'll roll out the hide, and they will identify any imperfections or flaws, so that way we can then cut around them, so that ultimately the leather that goes in the aircraft is the best possible quality leather. For vinyl materials or non-leather materials, we have an Eastman cutter that we use that can cut the material to the exact dimensions and specifications. And of course, all the carpet has to be cut as well. There's also a very tedious job because carpet's actually pretty hard to cut. Yeah, basically using a carpet knife. But at the end of the day, we end up with these beautifully, even for a trainer, which this is obviously for a Seminole, we end up with a really nice, robust interior that looks nice, but also will hold up to the repeated use that Seminoles typically get in a training environment. So again, it's just an immense amount of work. They take the actual side panels, which we build, and then they have to cover them in a material so that everything looks finished. Also helps with noise dampening. But every little bit you can see is such an immense amount of detail. So the door in particular, or any of the emergency exit windows, are just a little bit more work to put together. And now that we have all these accent pieces, which are different finishes, we have one that's carbon fiber, we have one that's kind of like a nickel or chrome, and there's a couple others that we have, and just kind of making those work and look beautiful and look, make sure there's no wrinkles, no seams visible, no imperfections visible, no glue visible. It takes quite a lot of work to do that, but we're lucky to have such a wonderful team here that really focuses on an attention to detail and really has a commitment to excellence. The bulk of the interior material comes from a company called Perrone. The leather line that we use in the M-Class or even the Seneca is a line called Duchess, and which is great because it gives us the ability to kind of shift colors as trends and tastes change without having to go through the process of burning each time. Because if you stay within that line, it gives us a little bit more flexibility with respect to certification. So we basically work with engineering to approve a particular line of materials that comes in different colors, and it gives us the flexibility to shift as demand shifts with respect to taste. And this smells like paint, by the way. So the process here in general, they come in through this door, which is where they do the bulk of the interior installation. The aircraft then goes through a series of stages to be prepped for paint. And then in the way back is where they do the bulk of the paint work, which involves laying out the paint scheme. And while we have these standard paint schemes each year, we change them about every 2 years on the M-Class. At the end of the day, the team here lays out each one of those schemes by hand. So it's not like there's a specific projection process that's used. It's truly done by hand by our skilled artisans. So once they finish the whole paint process, which of course each color is a separate masking. So they start out with a base and then they mask layer upon layer to get the different colored stripes. So each color again is a process, right? So once it's done, it comes here, and this is where they do the bulk of the detail work. And it's a lot of cleanup, making sure the lines are very, very clean. They're also finishing a lot of the interior work, anything that's left to be installed, anything that's remaining, so that the aircraft then could leave here. It'll then go back to flight line. It'll be flown again, because keep in mind, from the time that it was first flown, we've now installed an entire interior. So to ensure that everything still functions, which it does, they'll go over to the flight line and they'll do another flight with the aircraft and run it through a series of tests to make sure that everything's as it should be and meets all of the standards that are required by us. The process in general, from start to finish of building an aircraft and finishing the aircraft to where it's ready to be delivered, is roughly 4.5 to 5 months from the first piece of metal being cut to being finished here. Even with the pandemic, like I had mentioned earlier, Piper Aircraft continued to operate that entire time. We were deemed as an essential business. So while we had to make some changes in how we operated, like taking everyone's temperatures as they came on property, the use of face masks, a lot of additional hand sanitizing facilities, so that people could kind of make sure that they weren't spreading germs, and also maintaining social distance. And in some areas like this particular area, it's harder to do the social distancing because everybody's working in concert with one another and working in very close proximity to each other. So we had to be particularly attentive to the safety of the employees. But I think our safety team did a wonderful job. We actually stood up a COVID task force, and I think they did a great job of A, communicating with the workforce, and B, setting up the proper policies and procedures to protect everybody. And I think that's really evidence in the fact that we've been able to operate this entire time with minimal disruption. Thank you so much for joining me on the tour of the Piper factory here in Vero Beach. From the nearly 1,000 employees to our wonderful MMOPA members and our owners, thank you so much for joining us. And we hope to see you here soon, where you can visit the factory and see firsthand how we build your aircraft.